All right, Unit 7 warm up. What's the sum of all the angles in this figure? Anybody know? Sum of all the angles? Mark? 180. Why is it 180? How do you know? What? No, what'd you say? It only has 3 sides, which makes it a triangle. Good. So the sum of all the angles in this figure is 180 because it is a triangle. All right? We'll get into the triangle sum theorem here in a second. That'll kind of help solidify that concept. Next question. What is the relationship between A, B, and C? What's the relationship between A, B, and C? First off, what are A, B, and C? Are they angles or sides? Sides. John?
Right triangle.
Okay. Do we know what's the right triangle or not?
Yeah, I do.
You do? How do you know?
Because it's a right angle.
Okay. Is that a right angle, though? Guys, is this a right angle?
No.
No, it looks like one, right? But can I say it's a right angle because it looks like one?
No.
No. What do I have to have? A little box. Okay, so maybe this will help you tell me the relationship between A, B, and C. If this is a right angle, see, John, now it's right angle.
I don't see it. Because of the green marker.
Oh, okay, you kind of cheated from last time. Right? That's all right. That's all right. All right. Now what's the relationship between A, B, and C? Okay, it is a right triangle. Remember, these are the sides. C is called the
Oh, 90 degrees.
hypotenuse, right? C is the hypotenuse that's across the right angle. What are A and B called?
Like,
Legs, right? You have 2 legs. Triangles have 2 legs. The only thing you guys have in common, right? So, A and B are the legs. C is the hypotenuse. What's the relationship here? Anybody remember? A little louder, Matt?
A squared plus B squared equals C squared.
Good. Anybody know what that's called?
Pythagorean
Theorem.
Pythagorean Theorem, right? Pythagorean Theorem. Okay. Any questions about these 2 questions?
Oh, how do you spell
Hypotenuse, Hypotenuse. I like that word because it's hypo.
U.S. what?
U-S-E. It's hypotenuse. So we have to spell hypotenuse. Use, U-S-E, or use. Okay. All right, triangle sum theorem. What does the triangle sum theorem tell us? It kind of ties into that first question. Does this deal with the angles or the sides? Angles, right? What did this first question tell us about the angles of a triangle? They all add up to 180. That's what the triangle sum theorem tells us. Okay. The sum of all the angles in a triangle is 180 degrees. Right? The sum of all the angles in a triangle is 180 degrees. Somebody knocking on the door? So the sum of all the angles in a triangle is 180 degrees. That is the triangle sum theorem. Now, being a good math teacher, I can't just let you have that theorem. We got to make some algebra out of it, right? Right? What's the point of having a theorem if we can't do some algebra with it? So, 2 examples. Are these triangles? Yeah, 3 sides, right? They're triangles. Okay. So what is the sum of all the angles then? 180. Works for any triangle. Okay. Any triangle, the sum of all the angles is 180. So for this first one, if I'm going to find x, I know 180 will equal what? 10 plus 20 plus x. Right? Sum means add, right, Brandon? Okay. So I'm going to take all those angles, I'm going to add them up, Tony. Tony, come sit here right by Monica, please. Okay. So I'm going to add those up in order to find our x. Okay, now I have an algebra problem I can do. I'm going to combine my like terms, so we get 180 equals 30 plus x. What do I do now? Subtract 30. 180 minus 30 is what? 150. So x equals 150. Does that make sense?
You do it again.
Can I do it again? Okay. What's 10 plus 20, Josh?
30.
30. Okay, so that means I can rewrite this as 7 plus 20 is 30. So I can rewrite this as 30. Okay? Does that make sense? Now I want to solve for x. What do I do? Positive 30, so we
Subtract.
subtract 30. And 180 minus 30 is? You have a calculator if you need it.
150.
150. Okay, does that make sense?
Yeah.
Okay. All right, any other questions about that one? All right, now the second triangle. How many angles did they give me here? They gave me 2 of them, right? But they put this little box in that corner, didn't they? What does that box mean?
Right angle.
It's a right angle. So it's a right angle. How much does it measure?
90 degrees.
90 degrees. So then, using the triangle sum theorem, we know 180 is going to be equal to 30 plus
X plus.
x plus 20. Now, x plus 20 isn't a real, I mean, it's not, I guess it's a real angle measure when you combine them, but we're solving for x. When you find x, is that the angle? No, the angle is x plus 20. So whatever x is, we add 20 to it, that's how much that third angle is going to be. All right, so to solve this, we do the same thing. We combine like terms, right? Which things are like?
30, 90.
30, 90, and 20. 30 plus 90 is 120. 20 plus 20 is
140.
140. So 180 equals 120 plus x. Now what do I do? Minus 120.
Wait, that's 140.
It is 140. How do you get 120? Man, must be a Monday. Yeah. So I'm going to subtract 140. Thank you, Miss Marie. 180 minus 140 is? 40. So it means x equals 40. Okay. Any questions? Now, were we talking about angles there or sides? Angles. Okay, we're talking about measures of angles, right? Okay. Now the book, they measure angles a little, I shouldn't say they measure them a little differently. They just talk about angles a little differently. Okay, this book was the only place I've ever heard them talk about angles in this way. But the reason why we're going to discuss it is because they'll ask questions about what they call terminal sides and initial sides. Okay. Now, every angle, you can think of it as 2 rays. Does everyone remember a ray? Everyone remember what a ray is? Okay, it's where you have a dot and an arrow going in one direction, right? So I have an axis with the blue, and in the green I have 2 rays, don't I? Right? Every angle can be thought of as 2 rays that intersect at this point. What's that point called? It's the origin for the axis, but it's called the vertex. Okay, this spot right here is called the vertex. Okay, the vertex is the point shared by the 2 rays. Oops, no T at the other point. The vertex is the point shared by the 2 rays. Now your book likes to think about an angle as 1 ray starting here and then being rotated a certain amount of degrees. And the amount of degrees it's rotated, that's the angle it's making. Okay, does that make sense? So it's like I'm taking my hand, my elbow is going to be the vertex, the rest of my hand is my ray, and I'm going to rotate it, and that's how I'm going to make my angle. Okay, so my hand started here, that's called the initial side, and it rotates to here, which is called the terminal side. Okay, I don't know where they came up with terminal, but what they call it. Initial side is right there. This is called the terminal side. Okay, you can think of the initial side as the starting point for the ray, and the terminal side is the ending point for the ray after it goes through its rotation, or after it's rotated through its angle. This is our angle right here. Your book goes through this on page 461. So if it's not making sense, check out page 461, and that'll help you out. We should put page in front of that so we know. Okay. The book kind of has a nice explanation, a nice paragraph that you can read about it. So, but basically, they just think about the angle as we have 1 ray that goes across the x-axis, and that ray is rotated to make our angle. So, hopefully that explanation kind of helps. There's one or two problems that we'll have to do that involve the initial side and terminal side. That's what we're discussing. All right, any questions about the triangle sum theorem? Any questions? Okay, one more time. What does triangle sum theorem talk about? Angles or sides? Angles. Triangle sum theorem only deals with angles, doesn't deal with sides. Okay? So triangle sum theorem only deals with angles. Okay? The next theorem we're going to talk about is the Pythagorean theorem. Okay? Which question from the start of class does the Pythagorean theorem deal with? The second one. Hey, John, you were on a roll. Okay. The second question that we talked about beginning of class, that's Pythagorean theorem. Now, does the second question talk about angles or sides? Sides. Okay? So the second one talks about sides. The Pythagorean theorem deals only with sides. Okay? Now, what stipulation did we have to discover about the second triangle? What stipulation? What do we have to know about the triangle? What is it? Has to have a right angle. So this Pythagorean theorem, does it work for every triangle? No, only for what triangles? Right triangles. Okay? The Pythagorean theorem says for all right triangles. I'm going to double underline right triangles because students sometimes forget the triangles must be right. Okay. For all right triangles, a squared plus b squared equals c squared. Okay? If and only if, one stipulation. So this only works, basically if and only if says, this only works if what? What does C have to be? C has to be the hypotenuse. If and only if C is the, here we go, hypo 10 use. That's how I spell it, hypotenuse.
I've never even looked at that the same way again.
Yeah?
I know.
That's how I learned how to spell. You guys know good spelling. Okay, I'm sorry. So, remember, right means we have what kind of angle? 90-degree angle, right? Right means you have a 90-degree angle. And hypotenuse is the what? Okay, opposite of the right angle is the longest side. Good. Okay, so put that in box. That's kind of your key to the definition, or to the theorem. For all right triangles, a squared plus b squared equals c squared, if and only if c is the hypotenuse. So if I have my triangle right here, and you guys will be given triangles, and they might have different names. It might be triangle PQR, or triangle WXY, or triangle KHS. Okay, it might be those. They may have different names. Okay, but I don't care what they call these vertices. You guys can pick the names of these sides. Okay? If I'm going to use Pythagorean theorem, does it matter which ones I call A and B?
No.
No. But it matters where I put the C. If I'm going to use Pythagorean theorem, where does my C go? Opposite the right angle. Okay? There's a theorem in triangles, I think you guys learned it last year, that tells you the biggest side is across from the biggest angle. Okay? The biggest side is always across from the biggest angle. So if this is a right triangle, 90 degrees is my biggest possible angle. Right? So that means that whatever side is opposite the right angle, that's always C. Right? So when you're trying to use Pythagorean theorem, make sure whatever side is opposite this right angle, that's the one you call C. I don't care which one you call A and B, but that one is C. All right? Does that make sense? Yeah. And I'm using lowercase letters. So now I can call this one A if I want to, and I can call that one B. Or you can call this one A and that one B. It doesn't matter, as long as that one is C. Okay? Does that make sense? All right, any questions? Questions? Okay. Example for Pythagorean theorem, we're looking at page 460. Now 460 has a wonderful word problem for us. I know how much we love word problems, but trigonometry deals with word problems a lot. Okay, you see a lot of trigonometry in real world situations. Okay, anybody ever see the surveyors on the side of the road? Where one guy's looking through like a telescope looking thing and one guy's standing a ways away from with a stick in the ground? You guys seen that before? Okay. Well, that telescope looking thing that they're looking through, that's a very high-tech protractor. What do protractors measure?
Angles, I think.
Angles. Okay? So what they're doing when they're surveying is they're using angles and triangles to measure elevation drops. They're using angles and triangles to measure how far things are apart without actually taking out a tape measure and measuring them.
That's an easy one.
Okay? It is an easier way to do it once you know how to use the triangle theorems that we're going to learn in this chapter. Okay? All right. So we're going to look at page 460, number 1, B and C. Don't just read B and C, it won't make sense. We've got to look at 1 and 1A first. So 1 says, study the diagram below of a radio transmitter tower. Now I have tried to recreate that diagram. The book does a much better job than I do. Okay. The diagram's of a radio transmitter tower. You guys see the satellites at the top?
That's what that is?
Yeah, those are satellites on the top. Thanks.
I thought they were arrows.
Yeah, they're satellites. Okay. All right. So it's a radio transmitter tower. Okay. A cyclops smiley face. Yeah. Okay.
You get an A for effort.
Cyclops with one eye.
I'm not seeing anything.
You get an A
Yeah,
for
I'll show you
effort.
later. Thank you. Appreciate that. All right. Below, okay, radio transmitter tower, 2 support wires attached to A and E and to the ground at B and D. So B and D are on the ground, right? Here's A, here's E, these are the support wires. Okay, support wire, support wire. You guys see that? Okay. First, focus on the triangle formed by the tower, the ground, and the shorter support wire. So which triangle are you talking about, the left triangle or the right triangle? Which one is the shorter support wire?
Right.
The right triangle, okay? Well, they're both right triangles. Okay. So there's 2 triangles here, right? There's ABC and CDE, right? We're going to look at CDE. Now, assuming the radio tower is well constructed, we're going to assume that this angle right here is 90. Okay? That angle right there is 90. Now, they say if CD is 50, that means this is 50. And they say feet. If CD is 50 feet and CE is 100 feet, and then B says, how long is DE? This is DE, right? Now, what kind of triangle do I have? A right triangle. What theorem can I use? Pythagorean theorem, right? Because Pythagorean theorem works for right triangles and it helps us find hypotenuse, and it helps us find side lengths, right? Okay, not just for hypotenuses. Now, if I look at this triangle, CDE, okay, they already named it for me, didn't they? But like I said earlier, I don't care what you name the sides, as long as which one is the hypotenuse. The longest one. C has to be the hypotenuse, right? So, which one's my hypotenuse? Is it CE, ED, or DC? ED. Okay? This is my hypotenuse. I know that because it's across from my right angle. Right? What can this one be? B? Okay. And what can this one be? A. It doesn't matter which one's A, which one's B, as long as C is the hypotenuse. Okay, does that make sense? Yeah. All right, so if I'm going to do 1B, they want us to find DE. So 1B, what am I going to use? Pythagorean theorem. Pythagorean theorem says A squared plus B squared equals C squared, right? So I can plug in my A as 100, right? Plug in my B as 50, and we got to find our C. 100 squared is 10,000, good. 50 squared is 2,500, right? And we still have c squared. Now add those two together, what do we get? 12,500, good. Oh, that's too much. 125,000. So make sure we have zeros in the right spot. Okay. So now I have 12,500 equals c squared. Whenever I have something squared, how do I get rid of the squared? What is it? Square root. We square root both sides. The square root of 500 is, Doug? Good. 111.8, and our units are feet. Does that make sense? Yeah? Any questions? Questions? All right, 1C. Okay, 1C says, if we were asked to attach a support wire of 125 feet long from point D to the tower, how far up the tower would you climb? So point D is right here, right? Which side is my support wire? C right here, right? This one, right? My hypotenuse is, right? Right? So you're saying my support wire is 125 feet long. Am I going to have the same triangle? No, because the way it's shown right here, C was 111.8, wasn't it? Yeah. Okay. So C is now going to be 125. Okay. They ask us how far up the tower we have to climb. So which of these is going to change, the 50 or the 100? 100. Okay. So we got to find A in part C. Okay. Now, if I'm going to find A, do I just rewrite this and say c squared plus b squared equals a squared? No. Because this only works if c is the hypotenuse, right? Yeah. Right? So I still have to write it the same way. We still do a squared plus b squared equals c squared. And then when we plug in what we know, we get a squared plus 50 squared equals 125 squared. Okay, you guys see the difference now? Okay. We don't just rewrite it so the thing we want is by itself. Okay, that's not how we use it. Okay, that's not how you use Pythagorean theorem. In order to use Pythagorean theorem, your largest side has to be by itself. The other two sides are on the other side. So I get a squared, we don't know what that is yet. 50 squared is 2,500. 125 squared? 15,625. Thank you, Doug. Now, how do I solve for A? Was that? Good. Subtract 2,500. So then A squared equals 13,125, right? Yeah. Now what do I do? Square root, because we got to get rid of the squared, right? So square root both sides. Square root of 13,125 is 114 point what?
564.
Okay, we'll go there. Feet. So that means in order to attach that support wire, someone gets the lucky job of climbing up 114 feet at the top. Okay, Mike, any questions on how we did that, guys? Any questions? Brandon?
Would that work for B?
Would that work for B?
Yeah.
What do you mean?
We're trying to find B instead of A.
Yeah, if we're trying to find B instead of A, yes, that would work. Okay. Right. Real quick recap. Pythagorean theorem works for sides or angles? Sides. Angle sum theorem works for? Angles. Okay, triangle sum theorem is for angles. Pythagorean theorem is for sides.